Hi, my team will be presenting the applications of Green's theorem in vector calculus. Our group member consists of 4 people, which are Ame, Fazli, Izati, and Muklis.
For introduction, Green's theorem is a fundamental theorem in calculus that relates a line integral to a surface integral. It is named after George Green, who first stated a similar result in a paper titled An AC on the Application of Mathematical Analysis to the Theories of Electricity and Magnetism. Green's theorem is an important theorem in vector calculus that relates line integrals and surface integrals. It has two forms, a circulation form and a flux form, both of which require the region D in the double integral to be simplified connected. Green's theorem is not applicable in the following conditions, which are the region enclosed by the curve is not simplified connected, the curve is not simple and positively oriented, and the vector field is in three dimensions.
Question 1.
So for the question number 1, we are going to use the Green's theorem to evaluate the equation which the particle that starts at point -50 move along the x-axis to 50 and then along the semicircle x squared plus y squared equal to 25. First, we need to identify P and Q. So P will be yx squared and Q will be negative x squared. And then we need to find the curl. So the next step, we find the Py, which is the partial derivative of P with respect to y. And we find the Qx, which is the derivative of Q with respect to x. Then we're going to get Py equal to x squared and Qx equal to negative 2x. Since it involves in the semicircle, we need to change the rectangular form to the polar form, which is x equal to r cos theta and y equal to r sin theta. And the theta range from 0 to 2 pi, and the radius is from 0 to 5. So right now we are going to construct and evaluate the double integral. The first integrate with respect to r and the next integrate with respect to the theta. So after we have done both of the integration, we are going to get the final answer, which is -625 over 4 pi. That's all from me.
Maple solution 1. So this is the solution for question 1 using Maple. Firstly, we use with vector calculus command and then we get the output as shown in the table. Then we use with plot command to plot the graph and the output is also shown in the table. After that, we use implicit plot for x squared plus y squared equal to 25. The range for x is from -4 until 4 and the range for y is from -4 until 4. Then we let p equal to yx squared and q equal to -x squared. After that, we use partial derivatives on p with respect to y and partial derivatives on q with respect to x. Hence, we got curl equal to qx minus py. We convert the rectangular form to the polar coordinate and we evaluate the double integral to get the answer of -625 over 4 pi. Question 2.
Okay, so for the question 2 is the use Green theorem to evaluate the integral of -2x squared y dx plus 2xy squared dy, and C is the boundary of the circle x squared plus y squared equal to 4 oriented counterclockwise. So first we need to identify P and Q. So P equal to -2x squared y and Q is 2xy squared. And then we need to find the curl. So the next step we find the Py, which is the partial derivative of P with respect to y, and then we find the Qx, which is the derivative of Q with respect to x. And then we got the Py equal to -2x squared and then Qx equal to 2y squared. So since it involves the circle, we need to change the rectangular form to the polar coordinate. So x equal to r cos theta and then y equal to r sin theta. So the theta is limit to 0 until 2 pi and radius 0 until 5. So we set up the double integral. Okay, so we convert to polar coordinates and dA equal to r dr d theta. So x square plus y square we change to the r square, and then we got the integral of 2 integral 0 until 2 pi and integral 0 until 2 r cube dr d theta. So first we integrate r cube with respect to r, and then we integrate with respect to theta. So we got the final answer, which is 16 pi.
Maple solution 2.
So now I will be presenting the solution for equation 2 by using Maple. Firstly, we use with vector calculus command, and then we get output as shown here. Then we use with plot command to plot the graph, and the output is also shown in the table. After that, we use implicit plot for x squared plus y squared equal to 4. The range for x is from negative 4 until 4, and the range for y is from negative 4 until 4. Then we let p equal negative 2 x squared y and q equal 2 xy squared. After that, we use partial derivative on p with respect to y and partial derivative on q with respect to x. Hence, we got curl equal qx minus py. We convert the rectangular form to the polar coordinate, and we evaluate the double integral to get the answer of negative pi.
This is the reference used in completing this report. That's all from us. Thank you for listening.